Welcome to another Godalming College practical physics walkthrough. We're looking at the fourth week of your introductory practicals today, and we're going to look at the humble 2p coin and try and find out the density of a 2p coin. This is not going to be done in the easiest way. We're going to do it in a way that will really practice your experimental technique, gives us lots of opportunity to look at different uncertainties, and ultimately combine a load of techniques to find the density. So let's have a quick flick through to the lab script. What do you get given? We're going to give you some equipment, and it's all going to be on a nice tray for you when you walk into the lab. So let's have a quick look at that. You should be able to see that now. So you've got a little tray of 2Ps, you've got 50 gram mass. This is called a knife edge block, it's just a pivot, micrometer screw gauge, a couple of set squares and a ½ meter ruler. All that gets given to you. And the basic gist is we're going to use the ½ meter ruler and the masses to act as a balance. Use that using moments to find the mass of our 2Ps. Then, before that, we're also going to have used a couple of techniques to work out the diameter and volume of the 2Ps. So we've got a volume, and if you've got a mass and you've got a volume, you can find density. Hopefully, you will already have recorded these elements that you're going to actually have to measure in your lab book before you start. That'll make life really, really easy for you. Nice table, so it's really, really obvious. The analysis looks really small, doesn't it? That's because we're going to analyse it in much greater detail next week. So this week you're going to mainly do the experiment and a bit of quick and dirty analysis, and then we'll do far more careful analysis later on. So let's go back to the instructions. First things first, we're going to measure the thickness of the 2p coin using the micrometer screw gauge and a 2p. And it says you measure it in several different places. Hopefully you can see from the 2p that it's not completely flat, so of course we're going to measure it in several places. I don't propose to teach you exactly how to use a micrometer in this video. There are plenty of videos which I'll point you to that teach you that, and we will also show you. However, this is a ratchet. That is what we're going to use to tighten it. Please don't use it to untighten, because as you can see, it becomes unscrewed. So the ratchet is for tightening. Use the main barrel scale to loosen and tighten, and all you do is we're going to place the 2p in between the micrometer jaws, tighten with the ratchet, and we'll read it off. I'm just going to show you this reading, and hopefully I can get it focused. Come on. Let's see if I can just focus it. There we go. So you can see that we have got 1 and possibly 2 in the on the top of the main scale. I can definitely see 2 markings on the bottom of the main scale. So the first of those bottom markings is a half, the first of the top markings is 1 millimeter. So I definitely can see 1.5. Can I see that second one? Well, especially as I can tell from this sliding scale that I'm quite a long way around it, I can't see it. So basically I know it's 1.5 mils from the main scale, plus whatever I read off here. So that's 1.5 and it's 0.35, 0.36. So 1.5 plus 0.36, I make 1.86 millimeters. So this reads 1.86 millimeters. I'd do this in several different places. I'd record each one, and I would take an average to give myself an average thickness of the 2p coin. Right, we're now going to measure the diameter of the 2p coins, and I've shown you the arrangement of how you're going to do that. you can see that I've put 5 2p coins side by side, and I've put them up against the half-metre ruler so that I know that their bases are all in a row. Therefore I know that I'm going to be measuring the full diameter. I'm going to use 2 set squares, and I'm going to read off the reading. I personally have set it up so that it starts at 10, just to make my life a little bit easier about where I find the final point. And of course you're always going to make sure you get your eye right over it to make sure there's no parallax. So I can see that starting at 10, move my eye all the way across, make sure I can see it really carefully, and that is absolutely bang on 23. So 23 minus 10 is 13. Okie doke, so you're going to have copied this out already, and oh my God, what's going on here? And we're going to have stuck in 10 for our initial point, so that's 20, so there, that's 20, 23, so I'll make that 13, and therefore 13 divided by 5, which you can obviously do in your head, is 2.6. Or you could have a calculator, it's completely up to you. And we've now got our base values all held in place, so we can move on to the second part of the experiment. So we're going to create a balance and use the principle of moments. First things first, we need to get this ruler actually balancing on the halfway point. So half-metre rulers, therefore the 25 centimetre mark, in theory, should be the middle point. It's almost certainly not going to be. So all I'm doing is trying to find that balance point, and look, I'm putting my finger above and below. That is as close as I'm going to get. I'll try and move it a little bit further that way. It's gone. So just move it back. That's pretty good. And what I would normally do then is just get a little bit of something. The micrometer box is normally fairly helpful for this, and just stick it underneath the balance point, so the end point, so that the ruler will help stay there. Now I need to make sure that I record that, and amazing, this is miles off. I make that 25.9 actually, so I'm going to record that on the grid. So we've now got to record the position of coins and masses when it is balanced. So let's have a little look at that. Is place our stack of coins. I'm going to use all 5 coins. I'm just going to place them, try to move the ruler. Just going to place them in a nice even pile on the right hand side. Now what I'm going to do is place the 50 grams here, and look, I'm supporting it with my fingers. I'm just going to move it. I want to make sure that the slot is 90 degrees to the length of the ruler. And I'm just going to move it. The reason why I'm doing that is just so that I know that that line there is almost certainly where the centre of mass is, of that mass. A little bit further away. Make sure that coin stack is nice and neat. But that is pretty well balanced. Now I'm going to really carefully lift that off and place it down and hopefully not move anything. And now I've got it off, I can look at these 2 positions and record them on the sheet. So let's have a look carefully here. And I bring back the trusty set squares so that I can read off the position of both left and right. Okay, so you can see it. And from this I can see I've got, make sure set squares is level with the ruler. That is, the left hand edge is 4.5 and the right hand edge is 8.2. So I record that. Same with the 2p's, and I've got my set square carefully placed, and amazingly it's bang on the 47 mark. And if I go on this side, hopefully it's 48.6. It's going to be a bit trickier to get exactly perpendicular, but I reckon that is 48.6. Phew. So I've reset up the balance, this time just with one 2p coin, and I'm going to use a single 10 gram mass. I'll repeat the experiment, make sure I've got the same balance point, and this time I'm just going to slide it along and find that balance point again. Right, that's it. Again, I'm going to lift it off, and I'm going to take the measurements in identical ways. Using the set squares, find the left and right point, and then I'm going to record them on the sheet. So, everything's recorded. I haven't done the units because, of course, they're already put right next to the quantities. And there's a bit of calculation to be done. Position of the coins. As it happens, when you look at this list, I did the 50 grams and the stack of 5 first, and the single coin and the 10 gram second. It doesn't actually matter, you've got to do them all anyway. But let's have a look. So position of the single coin, well, 47, 48.6, add them, divide by 2, that will give you the centre position. Same for all of the others. So quick bit of calculation and I'll magically fill those in. Okay, let's calculate the volume of the coin. What have we got? We've got diameter of 2.6 centimetres, so that's 2.6 times by 10 to the minus 2 metres. And we've got pi times, I'm just going to make this a bit. So it's pi d squared over 4. So pi times 2.6, quickly calculate that. What's going on here? I make that equal to 5.3 times by 10 to the minus 4 meters cubed. That's the cross-sectional area times the thickness, which we had as 1.83 millimeters. So it's this. Volume equals area times 1.83 millimeters times by 10 to the minus 3, which equals 9.72 times 10 to the minus 8, I make it. So hopefully that's true, and that's meters cubed. Oh, I've just spotted, I wrote meters cubed there, that should be meters squared. So that's the cross-sectional area, that's the volume. And that's the first thing you're being asked to calculate. The next thing you've got to calculate is, using moments, the mass of the coin. So, let's quickly scribble this out. I would always do a diagram for this, just to get my head around it. Doesn't need to be that carefully done, but that was 24.1. This was 47.8. I'm just doing the centres now. 7.05. Just realised I've been a little bit sloppy with my sig figs. I've added an extra sig fig there, but I'm sure you'll be more careful. Right, I make that to be 17.05, and I make this distance to be 23.7. So there, all my distances sorted out. I'm just going to stay in grams. For moments, you can stay in grams and you can stay in centimetres because it's just a ratio using common units anyway. So as long as I don't mind my final answer being in grams, I can stay in grams. So the moment going this way is 17.05 times 10, which I'll make to be 170.5. Therefore, the moment this way is going to be the same. So if I want the mass, I divide that by 23.7, and that will give me the mass acting here. So I'll make that to be 7.19 grams for the mass of a single coin. So hopefully that made sense. I said I had 10 grams there. That's where I got my 170 from. Got my 23 here. From principle of moments, anti-clockwise moments equals the clockwise moments, and I've got equated that to be a mass of 7.19 grams. You are then going to repeat that for the 50 gram masses. At this stage, all you're going to do is try and just think from common sense which you think would be the most reliable. Sorry, we've got to calculate. I'm not going to calculate this for you, but if I've got a mass and I've got a volume, I'll obviously need to turn this into kilograms. So these we're doing, that is 7.19 times by 10 to the minus 3 kilograms. So I've got my volume, and I can just do mass per unit volume, and that will give me a density. Go on, let's just calculate. Okay, so mass over volume, 7.19 times by 10 to the minus 3 over 9.72 times by 10 to the minus 7 actually. I wrote 8 up there, but I've just had a quick look and I've just counted my noughts wrong. So I made that 8,130 kilograms meters cubed. Okay, I've only done that notation because I've gone off the screen. And hopefully you will get somewhere similar. That seems to be a perfectly reasonable density for a metal. Obviously you're going to have a little look later on about what it is. Now crucially, so you're going to repeat that for the 5 coins and you're going to decide which one's the best. Next week you're going to do all of the uncertainties and analyse this in far more detail. But hopefully that has given you a little flavour of what you need to do this week.